Hi friends, in this particular video I am giving you a brief idea about what are the various IO devices and how IO devices are interfacing to 8086 microprocessor. Okay, in the previous video I explained how 8086 is interfacing to various memory devices in both minimum mode as well as in the maximum mode. Let us see in this video how 8086 is interfacing to IO devices, especially 8-bit input port as well as if you take 16-bit input port, how your 8086 is interfacing to 8-bit input port as well as 16-bit input port. Okay, let's see. See here. See here, input IOD interface. See, input or output interface. Let us see in detail. Okay, if you observe the diagram once. See here, this is your input port. Generally, it's, we are also calling as a input port is like a buffer. Okay, buffer. So, what is the role of input port? Input port main aim is it will take information from the various input device, means keyboard or any input device. Okay, it will take information from the input device and that information will be transmitted to processor data bus. This is processor data bus. So the buffer is a one input port, and the role of buffer is simply takes the data from the input device and transmitting that particular data to the processor data bus. Okay. So this is the actual role. So buffer is also having this buffer is also having 8 input ports, and these ports are used to receive the data from the input device, and 8 output ports, and these 8 output ports, generally 1007, are used to transmit data to processor. So buffer is act like a intermediator or mediator between input device and processor. Okay, and it will transmit data to processor. So coming to other one is output port or output device. Output device generally we are calling as a latch. So the role of latch is it is also having 8 input pins and 8 output pins. The role of latch is latch will take the data from the processor. Okay, and that particular data is transmitted to any of the output device. Generally output device should be like a display device or printer. All are output devices. Here it will take data from the processor and transmit it to output device easily. Okay, so let us see in detail what are the various ICs for input port, what are the various ICs for output port, and how data is transmitting. Okay, here. So in this particular video, I will cover only input port, 8-bit input port as well as 16-bit input port, how it is interfacing to 8086 microprocessor. We'll see in detail. Okay, let us see other slide. Now here, see here in this particular case, we can observe the input or output devices can be interfaced with the microprocessor in 2 ways. So this is very important point to consider. So the input as well as output devices are interfacing to 8086 or microprocessor in 2 ways. One is called it as IO mapped IO. Okay, then other is memory mapped IO. Let us see what is IO mapped IO in detail. So IO mapped IO means here we are using 4 special instructions called as in, ins, out and outs. Okay, only these instructions are used in IO mapped IO. Okay, let us see what is in. Generally in instruction, in nothing but input, out nothing but output port, right? In nothing but input. So in instruction, copy the data from the input port to the accumulator. So only accumulator register can communicate it to IO device. Only accumulator register is having provision. No other register is receiving data from the ports. So in instruction, what is the role of in instruction? In instruction, copies or reads data from the port. Okay, in that with the help of accumulator. So with the help of accumulator, data is moving from the port to the accumulator. Or with the help of in instruction, data is moved from port to the accumulator. So generally, if it is a 8-bit port, we are using AL register. Okay, if it is a 16-bit port, we are using AX register. Okay, for example, I am using 8-bit input port, then we are using AL register. If it is 16-bit port, nothing but 2 ports are present, then we are using AX register. Okay, that is for receiving. Out instruction, nothing but copies data from the accumulator register to port. To the point, in instruction is nothing but reading or transmitting data from the input port to the accumulator. Whereas out instruction transmitting the data from the accumulator to the output device. Okay, that's the difference. Okay, these instructions are preferably used in the IO operation. Okay, okay. Anyway, these points are common, not only IO mapped IO, even for memory mapped IO also. 1, 2, 3, 4. First 4 steps are common. So the last 2 are important for IO mapped IO. Concentrate. What are the last 2? Here, this is important. The M by IO bar signal must be low. Low means we are selecting IO. 1 means we are selecting memory. So the M by IO bar signal is low means we are entering into IO mapped IO. See here IO, this side also IO means we should select IO. So when it is IO, if it is low, then our selected operation is IO operation. For that, M by IO bar signal must be low. This is important for IO mapped IO. The other is IO mapped IO operates in 2 modes. Name it as a direct addressing mode. Other is indirect addressing mode. See, if it is direct addressing mode, the number of address lines should be 8. Okay, so if you use IO mapped IO in direct addressing mode, we have only 8 address lines. Okay, if you use indirect addressing mode, the number of address lines should be 16. Okay, so these 2 are very important for IO mapped IO. One is the M by IO bar signal must be low, and the second, if it is direct addressing mode, we have 8 address lines. If it is indirect addressing mode, we have 16 address lines. Okay, in case of IO mapped IO. Let us see other type, memory mapped IO. So in memory mapped IO, you concentrate the M by IO bar signal should be high. In previous case low, now it is high. Okay, in that case we are selecting memory mapped IO. Okay, M by IO bar signal must be high. Second, the memory mapped IO may not have direct and indirect, only one type. So in that type we have 20 address lines. So the 8086 uses how many address lines for memory mapped IO? 20 address lines to identify any device. So these 2 related to memory mapped IO. So if it is a IO, we should remember things. Here we are using in, especially out instruction. In instruction, receiving data from the keyboard and sending data to accumulator. Okay, out instruction, sending data from accumulator to output device. Like that, in and out instructions are used, and 2 operations: memory mapped IO or IO mapped IO. If it is IO mapped IO, M by IO bar must be low. If it is memory mapped IO, M by IO bar must be high. In this case 20 address lines, whereas in that case 8 or 16 depending on the type. Now, okay, this is the basic overview of memories. Okay, memory mapped IO and IO mapped IO. Coming to here, let us see how 8086 is interfacing with 8-bit input port. So what is the title here? Interfacing 8086 with 8-bit input port. Assume this is our 8086. Okay, now I'm using, this is a buffer. It is act like an input port. This is now act like an input, buffer is act like an input port. Okay, what is the IC number for buffer? 74LS244 is the IC number. It is available readily in the market also. Buffer is IC number 74LS244. What is the role of buffer? Buffer having 8 input pins, call it as I0 to I7, and 8 output pins, call it as O0 to O7. Okay, and here buffer activating pin is there, OE bar. Okay, first we'll see briefly what are the pins and other. Later we'll see the complete operation, OE bar. Okay, then there is a one unit, call it as a decoder. IC number for this decoder is 74LS138. Okay, so here what is the role of decoder? Decoder performs 2 functions. One is decoder will activate the buffer. The second is decoder will provide address for this particular buffer. So decoder will give you address for this buffer, and decoder will also activate a chip selecting signal of this particular buffer. For this we use decoder. Now here we have 8 inputs and 8 outputs. Let us see what is the role of buffer. Buffer is nothing but input port, and it will receive data from the 8 input pins, and that information is transmitted to output devices. Here I am taking 8 input pins, nothing but a keyboard. Here I am taking 8 switches, S0 to S7, like that 8 switches are there. All switches are connected to common ground. Okay, now first switch is connected to I0, like that. Second switch is to I1, like that. S7 is connected to I7. Here I am connecting resistance with voltage arrangement, and this arrangement is used to limit the current. Okay, in order to provide the, or in order to control the current, we use resistance with voltage. Okay, and what is the resistance value? 10 kilo ohm. For example, voltage is 5 volts, means what is the maximum allowable current here? 5 voltage divided by resistance, nothing but 5 divided by 10k. Okay, that much current only it can allow maximum. Okay, for that case we use this arrangement. Now here, for example, let us see what is a decoder. Decoder having 3 input pins, call it as A, B, C. A, B, C. These 3 are called as decoder input pins. G1 bar, G2 bar, and G. These 3 are called it as a decoder control pins. And Y0 to Y7. Anyway, Y7, Y0 only he mentioned, but here output the decoder contains 8. Y0 to Y7. are called as the output pins of decoder. So generally all output pins of the decoder must be all zeros. When they are generating all zeros only by activating decoder control pins, nothing but G1 bar, G2 bar and G. These three are called as control pins of decoder, and A, B, C are the input pins of the decoder. Input pins we can select any value, not a problem, but control pins G1 bar, G2 bar, G must be activated properly. Here, see here, G1 bar when it is activating by giving 0. So that's why here in this example, he connected A3 address line with G1 bar. So A3 must be 0, then only it will activate. Similarly, G2 bar is connected to output of the OR gate. What are the inputs of OR gate here considered? A4, A5, A6. So output of OR should be when it is 0 if all inputs are zeros. Here A4, A5, A6, all three are zeros. Output of OR is 0. 0 give it to G2 bar, it is activating. So which are fixed? A3 must be 0, A4, A5, A6 must be 0 for activating these two. A7 is connected to G. So if A7 is 1, then only G is activating. For that, A7 must be 1, A4, A5, A6 and A3 must be zeros. A0, A1, A2, they are connected to input. We can select either zeros or ones, but A7 to A3 must be fixed as per the arrangement. Okay, not only here, if you want, you can connect this OR gate here. Accordingly, we can identify whether the values are ones or zeros for activating G1 bar, G2 bar and G. If these three are activating, their output Y0 to Y7 becomes all are zeros. Okay. Now, for example, here output Y0 is 0. So 0 connected to OR gate. Okay. Now it is 0. What is next one? Here I am taking one more OR gate. In that M by IO bar is connecting. Here for IO mapped IO, I already mentioned M by IO bar is low. Low means 0. Here I am giving 0. Read bar, for example, what is the role of input port? Input port sending data to processor. Nothing but processor receiving data. Means processor performing which operation? Read operation. For that, see here, read bar signal is now low. This is 0 for reading data. M by IO bar is also low for selecting IO. So this is here we are selecting IO. Here we are selecting read. Then what is the output now? 0. 0 means both inputs are zeros. Output is 0. So here this is 0. This is also 0. What is the output of R? 0. 0 give it to OE bar. Then it is activating. Like that, OE bar is activating. What is the name here? I am calling read bar and OE bar. Then output I am calling as a name like IO read bar, but it should be 0. This is also 0. Then output 0 is given to OE bar. It will activate. Okay, once it is activating, then what happens? See, buffer receiving the data from the keyboard, and that information is transmitted to lower byte of the processor because size of the buffer is 8-bit here. So that's why it will transmit lower byte of the processor. For example, processor. See here one important point is that whenever if any switch is closed, what is the equivalent binary value? 1. Whenever if any switch is open, what is the equivalent binary value? 0. For suppose processor wants to close all the switches, then how to write the program? So within the processor we are writing like this. Here move AL comma 0 FFH. FF nothing but all are ones. D0 to D7 all are ones. Okay, so generally remember one more point. If it is if higher 4-bit value is more than 9, means like A to F, the left side you should write 0. Otherwise, it will give you syntax error. Remember. Now move AL comma 0 FF means where in that case all are ones. If all are ones means all switches are closed. Then I'm writing like this: in ATH comma AL. Why I'm writing in? I already mentioned in instruction is used to send the data from the input port to the processor. For that we are using in operation. Output means receiving data from the processor. In that case, in ATH comma AL. So AL already having which value? FF. That value is now moved to ATH. ATH means this is the address of buffer. ATH is the address of the buffer. How we get AT here? If you observe, A7 is 1, A6, A5, A4, A3 all zeros. All are zeros. A0, A1, A2. Initial I am taking all zeros. Then what is my address? A7 is 1 and remaining all A7 to A0 except A7 remaining all are zeros. What is the equivalent XOR? 80. ATH is the address of this decoder. Address of this buffer. So this decoder performs giving the address for this buffer and also providing activating signal for this particular buffer. Okay, buffer activation signal and address of the buffer are generated by decoder. Then into 3. If you write like this, automatically all switches are closed. For example, if you write instead of FF, if you write 00H, then all switches will be open. Okay, like that we can interface 8086 with 8-bit input port. If it is 16-bit input port, what happens? Let us see. We need at that time 2 input ports here. See in this particular diagram, I am taking 2 buffers. Buffer 1, buffer 2. 2 buffers are there. Okay, one buffer receiving information from 8 switches, other buffer receiving information from another 8. Okay, this buffer sending data to lower byte of the processor. This buffer sending data to higher byte of the processor. Here one decoder is enough. Okay, one decoder. Here also I'm taking same A7, A6, A5, A4. A7 is connected to G means A7 is 1, A6, A5, A4 connected to OR gate, and output of R is G2 bar means it should be zeros. Output will be given to G2, 0, then it is activating. A3 must be 0, then only G1 bar is activating. ABC, we have A0, A1, A2. We can select 3 zeros for first buffer address. Then other combination 0, 0, 0 for first buffer, 0, 0, 1 for next buffer. Like that we get two addresses. 80 for this, 81 address is the lower buffer. Okay. Right, here also same arrangement we are connecting. See here also M by O bar must be low and read bar must be low, then output should be low, and Y not also low, then output both inputs are low means output is low, low given to Y bar it will activate. Same Y bar is also given to another buffer, then both buffers are activating at same time, and from this buffer 8086 receiving lower byte data, from this buffer 8086 receiving higher byte data. Like that we can interface 8086 with a 16-bit input port. For example, processor wants to close all 16 switches. Then which data it will send move AX comma 4FH. Okay. Then 4F means the 16 ones are there. Then it will enable all the switches into closed mode. Then in ATH comma AX. Here what is the size of AX? 16 bits. So then it will allocate the two locations 80 and 81. 80H is the address of first buffer and 81H is the address of second buffer. So now your processor giving information to 80H means buffer 1 and buffer 2. Like that we can interface 8086 with 16-bit input port. Okay, so in the next video I will explain how 8086 is interfacing with the output port. Okay, and later both the input and output combination also we'll see. Okay, in the coming video. Right, like that we can make interfacing easily 8086 with IO devices easily. Okay. Now, thank you for watching this video. Okay, if you really like, please kindly share this video to your friends and subscribe my channel.